On the top, we've got 9x squared plus 81x. Yuck. Hi, I'm Sarah. I've been a STEM teacher for 20 years, and I like to make math engaging and fun and not so scary for everyone, all ages. I do private tutoring and mini lessons and things like that. If you need more information or you want to reach out about tutoring and setting it up in person or Zoom, click the link and do the stuff. This is not a bad problem. This is a good problem. When you are getting into these really advanced factoring polynomials problems, you start to see a lot of patterns and you want to be able to recognize a lot of patterns. So when you have something like this, your first clue in your head, well, not your first clue. When you see this, you should think, oh, I add a factor. Remember, when you've got these fractions like this and they say simplify it and you go, how am I supposed to simplify that? It's so complicated, right? Think about a fraction, right? The only way to simplify a fraction is to like cancel things out, right? If you've got the number above the other number, right? So you can cancel things out, you can reduce it, right? You can divide by the same number and all that kind of stuff. So we want to start factoring. So the first thing that you look for with a factor is you're going to look for the greatest common factor. So the top piece, 9x squared plus 81x. Again, the thing that we're looking for is we've got a factor, right? We can factor and then we'll be able to simplify stuff. Okay, so the top, we look for the GC, well, actually for the whole thing, right? We're going to look for the GCF. So 9x squared plus 81x, I can pull out a 9x from both of them, and we're left with x plus 9 over, now here, I can actually take out an x from all of these too, GCF. So I'm going to take an x out of all of those terms. So then I'm left with x squared plus 8x minus 9. Sorry, that pause was just me thinking 14 steps ahead. Okay, now I look here and I go, okay, I can factor that some more. Now I know there's a canceling out, but we could do that now. We could cancel out the x over x if you want to. Or you could just leave it until the end. I like to just cancel all the stuff at the end. Okay. So x squared plus 8x minus 9. So remember back to, we're looking for two numbers that multiply to -9 and add to +8. Now, since this one's negative, it means we have to have opposite signs, right? Because a positive times a negative gives us a negative. So when I'm looking at this, I'm going to do, I can make this, right? I can factor this out to be x plus 9 times x minus 1. Okay, so I can factor, it's just a trinomial, right? So 9 times -1 gives me -9. +9 minus 1 gives me +8. Okay, so I'm going to go over here. I'm going to rewrite it another time, okay? Because now I'm going to rewrite this all because we have now rewritten this whole complicated thing into a whole bunch of stuff multiplied together. And it's going to be, and I'm going to put parentheses around everything just so it makes it a little bit easier to see that they are all being multiplied together, right? Actually, I'm going to do, so 9 times x plus 9 on the top over x times x plus 9 times x minus 1. Now, if I went through and I multiplied all of these together, I would still get the same thing up here, right? 9x squared, 9 times 9 is 81, 81 times x, blah, 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 right? If I multiplied all of these together, I would get the same thing. But now, it's the best part. With a fraction, if you've got the same thing on the top as the bottom, they cancel out because anything over itself is 1, right? 3 over 3, 1. 5 over 5, 1. X over x, 1. 14x squared over 14x squared, 1. It doesn't matter. So now, we get to cancel it all out. So I have x over x. Those are gone. I have x plus 9 over x plus 9. Gone. So now all I'm left with is a 9 on top and an x minus 1 on bottom. So that whole complicated problem is just 9 over x minus 1. It's mapped up.